everybody, happy spring. We're gonna blast into spring today making elephant toothpaste. So before we begin, I'm gonna show you the ingredients. We need hydrogen peroxide, the hydrogen peroxide you can get from your bathroom. We need liquid dish detergent. We need yeast. We're gonna need 1 teaspoon of yeast, 2 tablespoons of warm water, the warmest you can get from your tap, and you're going to need a 1/2 cup measuring cup, a funnel, and an empty water bottle. All right, so every good lab starts with a question. So our question today is, what ingredient causes the chemical reaction to take place? So I'm thinking about all of these different ingredients, and I have experience with all these ingredients. Now, liquid detergent, when I put it in my sink with water to wash my dishes, I don't get that foaming out of the sink experience that I'm going to get with the Elephant toothpaste. So I'm thinking that that's not going to be, the liquid detergent's not going to be it. So I'm thinking about the hydrogen peroxide. Now I know that when I put that on my hand it bubbles, but it doesn't seem to bubble uncontrollably. So even if my hand is wet, or if I just washed my hand and maybe there's a little bit of soap still left on it. So I'm thinking that it's probably not going to be the hydrogen peroxide. Now I'm thinking about the food coloring. I don't think the food coloring is going to do it either. Now the one thing that I don't have as much experience with is the yeast. Now I do know that when I put yeast in my bread dough or my pizza dough, it rises if I set it aside, and that's what the recipe calls for. So I'm thinking that maybe it's going to be the yeast. So if I was making a hypothesis, I would probably say that I would make the statement, the yeast is going to cause the chemical reaction in the Elephant toothpaste. Okay, let's see if I'm right. So now I have all of my ingredients. I have my safety goggles ready to go because I do not want to get hydrogen peroxide in my eyes. So if you go to my webpage, you can copy off the materials list and the step-by-step instructions and do this at home. So I encourage you to try this at home after we're done. All right, so I'm going to start off by putting on my safety goggles because I'm going to start off with the hydrogen peroxide. I'm going to get my water bottle here and my funnel. I'm going to put my funnel in and put 1/2 cup of hydrogen peroxide in my water bottle. Then I'm going to put a squirt, I know that's really scientific, but a squirt of liquid detergent in with my hydrogen peroxide. And I'm going to take a look, and I don't notice anything happening so far. So, yep, no, nothing so far. So now I'm going to get my food coloring. Now if you don't have food coloring at home, that's okay. You can do this experiment without food coloring. I'm going to go ahead and choose green because it is spring. And I tried this before and I only put 3 drops of food coloring in there and it wasn't a very dynamic color. So this time I'm going to put 6 drops of food coloring in. So I've got 6. I got my food coloring in. Now I'm going to look at it and see if the food coloring made any difference. Is there anything happening? There's nothing's happening yet. So my next step is to put my yeast in with the water, and I need to put that in the water and stir and make sure it's really combined before I put it in with the other ingredients. So I'm going to go ahead and put that in and stir this up, and I want to make sure that it's pretty well dissolved before I put it in there so it's not real lumpy or anything, and it'll be ready to go. Now when I put the yeast solution in with the rest of the ingredients, I want to pull that funnel out pretty quickly so that I can see the reaction that's happening. So if some of the yeast sticks to the spoon, you can just kind of get it off of there and keep stirring and make sure it's pretty well combined. So now I can see that it's pretty well combined and we're ready to go. So I'm thinking that this yeast solution has something to do with the success of this chemical reaction. So I'm going to use my funnel, pour this in here, and then pull this out, and then look to see what's happening. The reaction is happening. All right, there we go. There it goes. All right, so now we can kind of take a look and analyze what just happened. So now that we have successfully created the elephant toothpaste, now we can kind of talk about what happened on the chemical level. So the hydrogen peroxide decomposes into liquid water and oxygen gas. This reaction happens so slowly, kind of like a sloth moving up a tree, that it needs to have a catalyst or a motivator to kind of speed up the reaction. So the yeast solution is what speeds up the reaction. The addition of the yeast solution causes the eruption of the foam because adding that solution to the peroxide quickens the production of the oxygen gas. The liquid soap catches that oxygen gas and then creates this foamy elephant toothpaste. So if you want to change this up a little bit, instead of just getting the hydrogen peroxide from your bathroom, which is at 3%, you could get hydrogen peroxide like from a place that sells things for hair salons or nail salons, and they have hydrogen peroxide at 6%. Now, I suggest if you do that, that you get a deeper pan to put it in because it's going to be a little bit messier. Okay, so now how can we tie all this into something that maybe we've seen before? Okay, so if you have a cut on your hand, inside that blood and scrape and skin cells, there is an enzyme called catalase. And when you put the hydrogen peroxide with the catalase, it causes a bubbling effect. Now that bubbling effect is the high oxygen environment that's created from the oxygen gas. Now that environment is absolutely deadly to bacteria, and that's why your parents or your grandparents put that hydrogen peroxide on in order to kill the bacteria so you don't get an infection in your cut. All right, well, I hope you've learned something about chemical reactions today. I hope you keep learning and you keep watching.